Hello friends, today I am going to explain you 2011 CSIR NET Part C solution. So coming to the point of the question, what the question they have given, let f is a function from R to R, that is from real number to real number, be continuous function such that integration 0 to infinity f of x dx exists. Which of the following statements are correct? This is the question of CSIR NET Part C. It contains 4.75 marks. So more than one option may possible. The first statement, the first answer is if limit x tends to infinity f of x exists, then limit x tends to infinity f of x equals to 0. This is the first option. Second option they have mentioned, the limit x tends to infinity f of x must exist and 0. The third option is in case function is a non-negative function, limit x tends to infinity f of x must exist and is 0. Fourth option, in case the function is a differentiable function, limit x tends to infinity f dash of x must exist and is 0. First you have to understand in the question what they have given. They have given this one, that is f is the function from R to R is continuous, and second they have mentioned that limit, that is integration 0 to infinity f of x dx. So what does it mean? Coming to this point, given integration 0 to infinity f of x dx exists, and the second condition they have given, f is a function from R to R, be continuous. First you have to understand what is the meaning of integration 0 to infinity f of x dx. Okay, now I will consider first option and I will check whether these two conditions will help or not. The first option is if the limit x tends to infinity f of x exists, then limit x tends to infinity f of x equals to 0. First you have to understand this one, limit 0 to infinity f of x dx equal to area of function from 0 to infinity. Now I will consider one case. Here I will take limit L is greater than 0. So I have drawn this type of function. This is the limit x tends to L f of x equals to L. But consider this one, limit, sorry I'm telling limit, it is integration 0 to infinity f of x dx is not equal to finite, because if you calculate this area, its value should come finite, but in this case this is not finite. So this condition is satisfied, but this condition is not satisfied. Coming to case 2, that is limit is less than 0. Here I am taking limit less than 0. In this case also, limit x tends to infinity f of x equals to L, means as x tends to infinity we are getting some finite value, but the area, see the area, this area is not finite, because how can you calculate this area as x tends to infinity? So this condition fails, this condition pass. Now coming to case 3. In case 3 I have taken L equal to 0. So has this condition as limit x tends to infinity f of x equals to L, means as x tends to infinity it's tending to some finite limit value, that is L. And the second condition, integration 0 to infinity f of x dx equal to finite. Yes, the finite value we will get. It is this second condition is also passed, but in this case it is not approaching to the x-axis, the function value. If it approaches the x-axis, automatically these two conditions will be satisfied. Now coming to the second condition, the second condition says that the limit x tends to infinity f of x must exist and 0. In this case, they have not given compulsory, they have given if. You have to see if, means this, in this case this may possible, three cases may arises, but in this case, second option, only one case arises. Okay, so here this limit x tends to infinity f of x equal to L satisfied, this holds. And you can also calculate the area 0 to infinity f of x d equal to, you will get some finite value. So they are telling the limit x tends to infinity must exist, means some graph is going to infinity, but its limit L equal to 0, because the function value is touches to the x-axis as x tends to infinity, and whatever the area we calculated, it should come the finite. So second option is also correct. Come to the third option. In case the function is a non-negative function, limit x tends to infinity f of x must exist and 0. Yes, it is a non-negative because the function is non-negative. This is also, the function is non-negative. This condition is also passed and this condition is also passed, because we'll get the finite area, means you will get some real number. Coming to the third option, that is fourth option, D. What they have given, in case the function is differentiable, limit x tends to infinity f dash of x must exist and 0. Yes, you can find this is f of x, will get this derivative f dash of x, we will get here also, we get each and every point will get f dash of x, f dash of x, f dash of x, while as the function approaches as x tends to infinity, so the its limit will be 0. So if here also, at this point also, if you draw a tangent, it is parallel to x-axis. So the fourth condition is also correct, because in case the function f is differentiable function, limit x tends to infinity f dash of x must exist and is 0. So each and every point f dash of x is existing, and finally it is approaching to 0, because as you came to know that this each and every point the function is differentiable. As x goes to infinity, it touches it is parallel to x-axis, so its derivative value and it must be 0, its derivative value must be 0. So its derivative at x tends to infinity, automatically f dash value will become, f dash will be differentiable and its value is 0. So all A, B, C, D, all are the right option. This is a part C option. More than one answer may possible, but in this case the answer is A, B, C, D. Once again I will explain you the question. Let f is a function from R to R be continuous function such that integration 0 to infinity f of x dx exist. The first they have this condition, they have these two conditions they have given. First, this one is function from R to R. Second is integration 0 to infinity f of x dx must exist. This is the first. In these three cases arises. In this only one cases arises. The complete explanation I had given. This is 2011 CSIR NET question part C. It is for 4.75. Thank you, friends. In next video, again I will solve some 2000 related questions, that is main question paper. I may explain 2011, 12, 13. It depends on the questions. Thank you so much for your valuable time. Thank you, friends.